All right, this lesson is on representing proportional relationships. If you remember from the last lesson, we said the constant of the proportion is the unit rate. And we have k equals y divided by x. The relationship forms an equation, y equals kx, and the graph is a straight line through the origin 0, 0. So this is kind of our new key point for today. We talked yesterday about if the k value is the same for all the pieces of data in the set, that we do have a proportional relationship, which allows us to write this equation. The one thing that we haven't touched on so far is this going through the origin. So the graph, when we actually graph this, turns out to be a line, and it has to start at 0, 0. So that's something that we can visually look at. In the first example, a car technician took a car on 4 test drives. For each test drive, he recorded the miles driven and the amount of gas used. So this is our x, this is our y. So we do 100 divided by 4, which is 25, 50 divided by 2, which is 25, 25 divided by 1, which is 25, and 12 divided by 0.5, which is 24. So since that happened here, we do have a different k value. So we are not able to write an equation because this is a non-proportional relationship. If we were trying to find this k value, this would tell us the miles per gallon here. So unfortunately, this one's not proportional, so it wouldn't work out then. In number 2, do the points in the graph represent a proportional relationship? So we can look here. It does look like they tend to form a straight line going up here. Now, would this straight line come back here through 0? Looks like it would, but what we can do is we can actually still test these points. So remember, points are x comma y. So for this first one, I'm going to have 7.8 divided by 3, 15.6 divided by 6, and the last one, 18.2 divided by 7. So this first one here is going to give me a 2.6, and this one here will give me a 2.6, and the last one is a 2.6 as well. So the k value is 2.6. Our equation will be y equals 2.6x. Is the line here straight? Yes. Does it go through the origin? If we extend it back, yes, it in fact would, because we know it is proportional. In number 3, do these ordered pairs represent a proportional relationship? So really we just have to set up all of our division problems here. And remember, we're doing y divided by x. So first one will be 2.8. 8.4 divided by 3 would be 2.8. Sorry, I can calculator over here. 9.8 divided by 3.5, 2.8. And 11.2 divided by 4, 2.8 as well. So this tells me that my k value is the same for all of them, and the k value is 2.8. So my equation is y equals kx, so blank x, and our k is 2.8. So my equation is y equals 2.8x then. So this would in fact be a proportional relationship, and now that we know if I were to graph these points on a graph, this would actually be a straight line, and it would go through the point 0, 0 then as well. So number 4, this one is a graph, talks about pair prices, and it says to calculate the k value. What you are able to do is to basically look at the graph here and just basically pick a point. And it actually looks like it goes through the point 1, 2 right here, if you looked at that, or you could do 2, 4, or even 3, 6. Those all seem to be nice even points that are working out here. The rate is going to tell me the price per pound. So the price per pound. So now here's kind of what happens. When you actually look at the graph and you see that it is 0, 0, so it goes through the origin, and it is a straight line, yes, that automatically tells me this is proportional. So what it tells me is that I don't have to calculate multiple k values. If I know that it's a straight line through 0, 0, and it's proportional, then the k value is going to happen at any one of those particular points. So for example, this one is the point 1, 2. So to get my k value, I do y divided by x, or 2 divided by 1, which is just 2. So my k value is 2, which means my equation is y equals blank x. K is 2, so we plug that in. The equation of this line is y equals 2x. And it asks me what's the unit rate. When I have a proportional graph, a really special thing happens. We can always find the unit rate when x equals 1. That's the way it works. And if you notice in this k value that we did, $2 per 1 pound, that's a unit rate right there. So $2 per 1 pound, the unit rate here is $2 per pound with this relationship. In number 5, we're going to start to put some of this together here. The distance the grasshopper jumps, calculate the constant of proportionality. The rate is going to tell you the distance, the feet per jump. So again, we're able to know this is a straight line through the origin, which makes it proportional, which means I don't have to calculate multiple k values. I can just look at one here. So let's just take this one, for example, this 2, 3. So to get my k value, I'm going to do y, which is 3, divided by x, which is 2. And that's going to give me 1.5 is my k value. Now the nice part is, once I find that k value, guess what? That's my unit rate. So it's just 1.5 feet per jump. That is my k value, so y equals 1.5x then. If 1 is not a really obvious point, for example, here it is 1.5, we could have used that one. If it's not, you actually do just need to pick another point, do the y divided by x, and that gives you your unit rate then. In the next one, the constant of proportionality is 3. Which point does the line representing the relationship pass through? Circle all that apply. So if the constant of proportionality, that's k, is 3, I have y equals 3x is my relationship. It also means that if I do, remember k is equal to y divided by x, so if I do that, it means I should get 3. So I can do a quick check with these actually, and just do 17 divided by 4, that is not 3. 12.6 divided by 4.2, that is 3. 20 divided by 7.5 is going to give us a 2.6 repeating, so that is not going to work. And the last one, 34.5 divided by 11.5 is a, oops, typed that in wrong. That gives us 3. So there's actually 2 answers here that work out for this one. And I was able to find that because all I had to do was get that k value to be 3. So y divided by x had to be 3.